Okay, let's try some examples. So what if we said make a particle representation for steel wool rusting, and I tell you that iron, I'm going to give you the unbalanced word representation. Iron interacts with oxygen to form iron 3 oxide. Now, you don't know this because it's not predictable yet, but iron 3 oxide is a type of compound that exists in formula units, and it has 2 iron atoms stuck to 3 oxygen atoms. You would have to know that to be able to complete this. So, if I wanted to work this out, you could pause this and try it on your own. Okay, so I am going to show this as iron. Now, why did I choose one circle? Because iron is a monatomic type of element. It's not one of the diatomics. This is representing oxygen, and I know that because oxygen is it's a diatomic element, as I found on my element list, so I have to put 2 of them together. To represent one of the iron 3 oxides, I told you that it's 2 irons with 3 oxygen, and since I picked gray to represent iron and red to represent oxygen, I'm going to stick with that and put 2 grays and 3 reds. Now, I like to alternate them, but if you smushed them together, 2 grays on the left and 3 reds on the right, it's fine. Okay, notice that this is now my unbalanced particle representation. I can go about balancing it. Here I'm going to show you how to balance it. So there's a few rules, and this comes back from our original description of what we're doing here. So 1, I can draw any additional particle that I need to make it balance, but it has to be one of these types of particles. On the left side, I can only draw either single gray particles, meaning iron atoms, or a pair of red atoms stuck together representing oxygen. Those are the only 2 because I only have 2 reactants, iron and oxygen. I only have 1 product, so I can only draw these kinds of particles on the product side. And I'm just going to add more until I have the same number of each type of atom on both sides. So let's step through this one. In this case, I see that I have 1 gray, 2 reds on the left, and 3 reds and 2 gray on the right. So neither one of them is balanced. I'm starting with the red atoms. Again, I could have chosen to start balancing the gray and then pick it doesn't matter, but I chose the red. So I begin saying, since I only have 2 on the left and I have 3 on the right, I know I need more on the left, so I add another one. Unfortunately, 1 particle of oxygen was too few, but 2 particles is too many. So I leave it and I go fix the product side because I can't take less, so I'm going to go to more. So now I'm going to put another of the product particles here. So now I have 2 red, 4 red, so I have 4 red on the left and 1, 2, 3, 4, 5, 6 on the right. So now I have 4 on the red, 6 on the right. Again, notice that when I had 1 of these particles of iron 3 oxide, it was too few red particles, and now I have too many. But I leave it as too many, and I switch back to the reactant side. Now I say, okay, what if I add another red over here? Again, it has to be a set of 2 oxygen atoms. So 2, 4, 6 oxygen atoms on the left, and 1, 2, 3, 4, 5, 6 oxygen atoms on the right. So notice that if you can go back and forth up to 3 times, it will finally balance. If you keep going back and forth 4, 5, 6 times from reactant to product side, something's wrong and something messed up. But it certainly happens that you can go up to 3 times. You increase one side, it's too much. You increase the other side, it's too much. You go back and fix it. Now our reds are balanced, but our grays are not. I have 1 on the left and 4 on the right. Okay, so now I'm going to balance the gray atoms by adding 3 more on the left, since that was pretty simple. So this is now my balanced chemical reaction in particle form, is that I have my irons, I have my oxygens, and I have 2 of these. Now let's rewrite it in word form, and I have to add in the quantity of each substance. Now I'm going to use the same wording we originally began with. 4 atoms of iron interact with 3 molecules, 1, 2, 3, of oxygen to form 2 formula units, 1, 2, of iron 3 oxide. And here was my 4 atoms of iron. Now, if I wanted to write the chemical formula representation, I'm simply counting them up. So to represent 1 particle, I'm going to say this 1 particle is described as iron, so I'm going to put the chemical symbol of iron, Fe. This is oxygen, but there's two of them together, so I need that subscript of 2. So I'm representing one of these as O2. So the chemical formula is kind of describing what one particle looks like. So in this case, I have 2 gray, Fe2, and 3 oxygen. So you may like to keep a key over what's red and what's gray. If you had said O3F2, that's also okay. There is a preferred order, but we're not getting into it in this class. The second thing I need to do is now go back and do a count. So notice that the number in front is counting how many of that type of particle. 1, 2, 3, 4. So that's a 4 Fe. 1, 2, 3. This is 3 O2. And 1, 2. So that's 2 Fe2O3s. Just to bring up a couple of things, it's more vocabulary. We talk about limiting reagents. We can't always add materials in the same exact ratio in the chemical reaction. The starting amount that runs out first is going to be considered the limiting reagent, and the material that's left over is said to be in excess. Now, this happens all the time when we're making food. A lot of recipe work goes the very same way. So if you had a pack of 6 hot dogs and a pack of 8 hot dog buns, if we're considering that people will only eat a hot dog in a hot dog bun, then that means that we only have 6 hot dogs to package at the end. We run out of hot dogs, so that would be considered the limiting reagent, and we still have 2 leftover hot dog buns. That would be the excess. Another way of looking at this from this particle reaction is if I have 8 atoms of iron to react with 8 molecules of oxygen, what is the limiting reactant? And don't forget that our our chemical formula was it takes 4 irons to react with 3 molecules of oxygen. Okay, so I kind of like to circle a set of 4 since I need 4 for this reaction. So I have 4, I have 4 more, so I have enough for 2 reactions worth of the iron. Over here, I do the same thing. I'm going to do circle sets of 3 though. 1, 2, 3. So that's enough for 1 batch. 1, 2, 3. That's enough for 1 batch. And I have 2 left over. I don't have enough for 3 batches. So note that since I have enough for 2 here and I have more than 2 here, this is the limiting reaction. I'm going to run out of iron first. And I'm going to have excess reactant. So I could say that there's enough for 2 batches. So it's going to end up making 2 of my products for each batch, right? I have 2 of these being made, so this one will make 2, and this set will make 2 more, and I'll have a total of 4 units of Fe2O3. And when I'm done, I can see I have 2 oxygen molecules left over.